So just like the singularly linked list video, it'd be awesome if you follow along. That's the best way you're probably going to learn this, is actually typing this out. You won't be able to copy and paste off the screen, obviously, but you can type this out. It's the same code as from before. So, and we're going to start here. Make sure this is down here. And we have our three notes, right? So we have first, second, and third here. So I'm going to draw these in real quick. First, second, and third. All right. So in here we have a name, right? It's going to be equal to, for this one, is going to be Alice. And this one we're going to call, I'm just going to do NA because it's shorter, Bob. Then NA again. And we have Carolyn. All right, cool. And we have to make sure we put our next in there. So I'm just going to do NXT for next. And this has, see, first next is at second. So here's all the addresses for all of them. So at second is 98. So 98. And next is second has a next as well as third. So that's X42. And we have a next here. And that points to null, right? Because that's a null pointer. So I'm going to put null over here. And boom, boom, and boom, right? So we have our list. This is the head of our list or the root of our list. And now we're just going to add one minor change. And the issue with this list right now is, let's say I give you a pointer to second, right? And let's do node pointer. Let's say we did root is at second, right? So now in our picture, we can quickly add that. We have root is pointing here, right? And the issue is we don't know where first is because it's behind us, and we have no way of moving backwards. All second knows is what its next thing is and its name. So root only knows what second knows. So it can move this way, but can't move this way. So we can just simply add a pointer. So another node pointer to previous. And now we can add all those in the boxes. So previous equal to, right now it's just junk data in all of these. Right? And now we need to basically set our previous pointers. So don't want to wipe that. So let's leave root down here. Let's go here. So first dot previous should really point to equal to null pointer, right? This right here, the beginning of the list, should point to nothing. So null pointer is the safe thing to do. Let's go second dot previous, and that should point at first. So at first. And third dot previous equals at second. There you go. Now I can add all those in real quick. So let's do, so this is null pointer. This is x00, and this is x98. So these previous pointers, I'm actually going to draw really quick. I'm going to draw them in yellow. So these go this way, right? And this one goes to null, goes to nothing, right? So now I can move back and forth. That was the issue with having a singularly linked list, right? And it may seem more complicated, and it's slightly more complicated, but it's just comfort of using these a lot. Both forwards, just singularly linked list, doubly linked, circular, all these different things. It's just a lot of comfort in practicing. So just like the last video, I'm going to propose basically a challenge problem. And it's actually going to be what I said earlier. given any node pointer to anything in a list, print out what the first element in the list name is, right? So pause the video, try it yourself, and I'm gonna write it out and see if I can do it. I should be able to, considering it's my example, and then come back. All right, so void shouldn't do anything. Find first. So just take a node pointer root. Or I'm gonna call this cur pointer. Cur pointer. Doesn't matter what you call it. All right. So I'm gonna get rid of all this real quick, so I don't have to look at it. All right. So if we're passing a pointer, we should check first if cur pointer, if not, right? A lot of things whenever you're passing in a pointer, a good thing to check for first is to check if it's null. So if null pointer, return and print nothing, right? So we should just return here. And that's basically just a safety check just to make sure. It's a good habit to get into. All right, so now, considering we're going backwards, I'm gonna do while cur pointer. So while it's good, we don't necessarily need this, but I think it's a good practice to have. Now I'm thinking about it. Let's see here. If cur pointer previous, not. So if it's null, what we're gonna do is cout cur pointer name. I don't know why I did that. And then is the first item in the list. And now, nice and fancy. And so, just like the last time, I'm gonna test this out, and I know it's wrong already. So, find first, and I'm gonna pass in root, right? So I would say figure out what's wrong. I know I'm just gonna give you the answer, but there's something that's not happening. So when we go over here and we make ./a, and as you notice, nothing's happening. What's actually happening is getting stuck in this while loop, right? So cur's previous is never null. So if you notice, if we pass in first, so the first thing in the list, right, it should work. Or, yeah, warning, of course. That's what happens when you use flags. And you see it keeps printing out Alice. And the problem is, so one problem that we just noticed is we should probably return here and break, right? The other thing is we're not moving this cur pointer at all. This cur pointer will forever, if we go back to our example, right now root or cur pointer is pointing right here. It's never ever ever moving. So what we'll need to do is make sure to set root. And if we do root equals root previous, then what will happen is it will point here and it'll look and it will get its previous value, and now instead of root having the value of 98, it will be gone, and now point over here, and say we had 100 things, it will keep moving backwards. So I'll put that in the code real quick to hopefully make a little bit more sense. No. Okay. Get rid of this, get that out of the way. Now we should do, outside of our if statement, cur pointer equals cur pointer previous. I can't type today. There we go. And this should work. So let's see if it works on the first item in the list. Oh my gosh, did I uncomment that? Yes, I did. This is what I get. make dot slash a. So there you go, Alice. And if you, let's just do at third here. So let's say we're given the last thing in this list. Make sure it works. And there you go. All right, so next I'm gonna do circular linked lists.